are about transformations and about what changes when we see these. So can you describe the transformation on the first one, guys? Anybody know what that would change? Yes, it is a horizontal compression. What does that mean? Does it change x's or y's? X's. And so it changes this x-intercept from -1 to -1/2. It would change this x-intercept from, what does that look like, 6 to 3? Okay. It would not change the y-intercept. It would still be here. And this peak that was at almost 410 would still be at 10. It would just be over here at 210. So the graph would be squished in like this. Okay? Everybody good? The x-intercepts would change, not the y-intercept. Okay. Let's see if I can drag that. Well, not in one piece, but kind of in two maybe. So it would look like that. All right, 2f of x, what is this one doing? This is a vertical stretch. So it is changing y values by a factor of 2. So where this crossed like a little bit above 1, it would cross above 2, maybe even almost to 3. This would still be the same x-intercepts, but like where this value is at -3, I don't know, 7, it would be at -314. It's going to go up faster. So this is at 10, so it would be clear up at 20 somewhere. So on our graph paper, it would just go off the top because it's twice as tall. Okay? Any questions? That one would be kind of hard to tell. All right, I'm going to go ahead and just erase that one. What about the next one? Okay, so this one is reflected over y. So what is that going to change? Yes, so instead of crossing the x-intercept at -1 over here, it's going to cross over here. Instead of being at 4 over here, it's going to be at -4. Instead of there being a peak around 310 or 3.510, it's going to be over here somewhere. The y-intercept would not change. So this value over here that was maybe -3.8 would be +3.8. So it would look like it reflected. Everybody good? Left to right, changing x values. X-intercept. And the last one? Yes, this is reflect over x, which changes the y coordinates. So the x-intercept would still be the same, but where this one was at -2, +1.5, it's going to be down here. Where this was at -3.8, it's going to be down here. The y-intercept would reflect down here somewhere. Like this value that was 2.8 would be down at -2.8 and so on. Why am I aiming for that green dot there? That green dot is nothing. Sorry. It would be back here again. Okay, does that look about the right size? I don't know. Like it flipped over? Okay, close enough. Questions about those differences? All right, so on worksheet 12 today, we're going to talk about inverses. You've done inverses before, possibly starting even in Algebra 1. An inverse function is where you switch the x's and the y's. Does that sound familiar? Okay. The issue today is we're going to talk about what it means to stay a function and what's called a one-to-one function. A function is one-to-one. If its inverse will also be a function. We're going to have to find the equation, including domain restrictions. Verify two equations are inverses. This is where we put one inside the other, and they should cancel out and just equal x. And graph a function and its inverse, which again means switching the x's and y's. All right. So the inverse of this relation here is this relation here. They took all the xy ordered pairs and they flipped them. The graph should look like it reflected across this line y equals x, which is kind of weird. It's not a transformation we're used to, okay? It reflected across that line y equals x. So if I folded the paper along that red dotted line, this green parabola would match up with the blue parabola. Now, one of those is a function, the blue one is, but the green one is not because it fails the vertical line test. So for that reason, these are called inverse relations, not functions, because the inverse was not a function. Notice that these inverse relations are reflections of each other over the line y equals x again. This is true for all graphs of relations and their inverse, even if it's a function. Okay, we are most interested in functions whose inverses are also functions. When that is true, we're going to write the inverse with this notation. It does not mean 1 over, okay, does not mean 1 over x. It is the notation used for inverse of f of x. Don't ask me why, because it doesn't make sense, because I didn't get to write the rules for math. Okay, note all functions have inverses, but not all functions have inverses that are still functions. There we go. Say that right. All right, if a function passes both the vertical and horizontal line test, so to pass the vertical line test will make it a function. But if it also passes the horizontal line test, then its inverse will be a function. And it is called a one-to-one function. I don't know why they don't say that on the same slide, okay? So two relations are inverses if and only if one has the element BA and the other one had the element AB. So you can switch the XY ordered pairs. If the inverse of a function is also a function, we denote it with that notation. To be able to tell if the inverse is going to be a function, you do the horizontal line test. If a function, which means it passes the vertical line test, also passes the horizontal line test, it is said to be one-to-one because every x value matches with exactly one y. So there aren't any repeated x's or y's. So graph this on a calculator and decide if it has, whether its inverse will be a function. This one's done for us. Is that this gonna pass, guys? Passes the vertical line test, but is its inverse gonna be a function? Does the inverse function exist? No, because it fails the horizontal line test, okay? Let's talk about some of these. So graph this on your calculator if you need to. Anybody know what that looks like already? Well, it's these little reciprocal things. Is that going to pass the horizontal line test? Probably not the way I've drawn it, but yes, it's supposed to. So this would have a function that is an inverse. Now, think about that for a second. If I were to draw this line, guess what? The function is its own inverse. okay? If you flip it across that line, it's exactly where it is. But just write yes or no. Okay, picture this one in your head. I don't think you need to graph it on your calculator. You sure can, but will this have a inverse function that exists? Okay, it's a function, but does it pass the horizontal line test? Okay. It would have an inverse. It would look like this, but it's not a function. Inverse is not a function. Okay, what about this next one? I don't know what that looks like. What? Is it? I don't have any idea. Like this way? Oh, thanks. So it's this. I'm thinking yes, though, that the inverse, that it would pass the horizontal line test. I know it looks really horizontal over here, but if you continue to put bigger and bigger values in here, it would get smaller and smaller, closer to zero. The inverse would look like this, I'm thinking. Does that make sense, guys, if it passed across that line? So that was a yes. All right. This time we're going to actually find the formula for those, or the equation for those. If a function passes the horizontal line test, then it is said to be 1-to-1. That means its inverse will be a function. If a function is 1-to-1, it has an inverse function such that the domain and range also switch. Okay? So if this was our original function, say square root of x minus 2, the domain is 2 to infinity, left to right. And the range is 0 to infinity, bottom to top. Is everybody with me? The inverse function is going to look like this, because it's going to be reflected across this line. So the domain will switch and the range will switch. The range will be y values from 2 and up, and the domain will be x values from 0 to infinity. All right, so here's the steps to finding that algebraically. Use the horizontal line test to confirm the inverse function exists. If it does, you replace f of x with y, and then you interchange the x and the y. So you switch x's and y's, and then you solve for y again, and replace it now with the inverse function notation, and state any restrictions on the domain. All right, so the first one is linear. You don't have to do this one, it's already done on your worksheets. But this would be y equals 1/4 x plus 3, which is a line, so it's going to pass the horizontal line test. Everybody with me? Then to find the inverse function, you would switch the x and the y. What would we do first to get the y by itself now? Subtract 3. And then, how to get rid of a 1/4? Yep, multiply both sides by 4. And we could either leave it 4 times the quantity x minus 3, or we could distribute it. And then, because the inverse is a function, we can rewrite it in this notation. Okay? Any questions? Ready to try one? So let's try number 4. Would this pass the horizontal line test? It would cross down at -4 and be going up 2 and over 1, right? There's the original function. All right, so how do we write the inverse? Well, first we write that as a y, but then what do we do with the x and the y? So this becomes x equals 2y minus 4. Solve for y. So what do I need to do? Algebra 1 brain first says to do what? Add 4 over to the other side. And then we need to isolate y, so we need to divide everything by 2. And you could leave that x plus 4 over 2, or you could write it 1/2 x plus, and then the 2 goes into the 4 twice. Okay? And either one of those could be written as the inverse of the original function. If we graphed it, guys, if we graphed it where it used to have a y-intercept down here of -4, it would have an x-intercept of -4. Where it had an x-intercept of 2, it would have a y-intercept of 2. Whoops, I didn't draw that well. Let me see if I can undo that. Well, it would look like this. Great, what did I just do? So the x's and y's would switch, and it would look like it reflected across the line y equals x, that they folded in half, okay? What about this next one? What is this a graph of? Parabola shifted to the right 1 and up 2. So the question is, does it have an inverse function? No. It says if it has an inverse function, we're supposed to find it. We'll revisit this question later today. We could restrict the domain so that it had an inverse function. We could say I only want half the parabola, but for now it does not. So we're going to move on. Number 6. Ooh, what does that look like? Does it move over here and have like this? Does that seem what it's doing? Okay, so we're going to say yes, it has an inverse. We're going to make this a y. Then we're going to switch the x's and y's. So we'll say x equals 5 over y minus 2. What are we going to have to do to mess with that? I want the y by itself. Multiply by 5 on this side would just become a 25. Can we kind of cross multiply for a minute here? So we would get 5 times 1 is 5. Going this way, we would have x times the quantity y minus 2, or xy minus 2x. We're trying to get the y by itself. So what do we need to do next? Add the 2x over to this side. And then divide by x. And then we can replace y with this notation. That's supposed to say to the -1 up there. Sorry, looks kind of messy. All right, which there would be an asymptote up here at 2. Yeah, I don't want to try to sketch that one. Let's go with number 7. This is a cubic that has been shifted up 4. So if you graph it, it looks like that. What are you thinking? Yes, that would have an inverse that is a function. So this is y. If I switch the x and the y, it'll say x equals y cubed plus 4. Now how do I get the y by itself? Subtract 4. And then cube root is correct. So I need to cube root both sides here, which will give me y equals the cubed root of x minus 4. Or we can put it back in inverse function notation. All right. I want to show you on the calculator, maybe, yes, okay, here it is, that this is working. It is going to look a little funny because it's not going to be stretched. So our calculator likes to stretch things funny. We can do what's called a zoom square and it might look okay. But the original function was x cubed plus 4, is that right, guys? And the new one we came up with was under math, the cubed root of, and x minus 4 all in the radical. Isn't that what we had? Okay. Now, if I graph those, if I just do a zoom 6, they do look kind of inverse-ish. Okay. I'm actually going to go back here and put the line y equals x. I think I could even make it dotted. If I go right there, and I could make that dotted. But this is, yeah, that didn't work. Oh, it is dotted. It's just so thick that you can't tell it's dotted, hardly. The blue one. What I wanted to show you is that if you do a zoom square, it squares things up so that they do look more like they would fold across. Does that look better? Okay. The dottedness didn't help much here. I could have, I think, made it thinner somehow. I don't think I want to mess with, oh, there. There, now it's a nice thin. Does it look like a reflection across that line? Excellent. All right, let's move on. These are the kind that, of course, are what we do in pre-calc because they're tricky. Why is this going to be tricky? Because there's an x in two places, right? So when we switch the x and the y, we're going to have a y in two places. The process for these, after you switch x and y, okay, is going to be cross multiply, and then it's going to be to isolate the y's on one side and factor and divide. That's the lengthy process before we even get started. So you might want to write that down somewhere, because when you get it wrong on the quiz, I'm going to say revisit worksheet. Is this 12? For the process. Okay. First of all, anybody want to sketch that x divided by x plus 4? You would need x divided by the quantity x plus 4. And passes the line test, yes? So we're good? All right. So we... What? It passes the horizontal line test. It gets closer and closer to an asymptote, but it does pass. No. All right, so we're going to switch the x's and y's. So it says x equals y over y plus 4. Then I wrote up here, you switch. Check, we did that. Then you cross multiply. That's what that's supposed to say. So put this over 1 and cross multiply. Well, going this way, you just get a 1y. Going this way, you get x times the quantity y plus 4, or xy plus 4x. You have to go ahead and distribute it, because now we're supposed to isolate the y's on one side of the equation. So what do I need to move over there with that other y? The xy, and when I subtract an xy, I have y minus an xy equals 4x. Can I combine a 1y with a minus xy? No, they're not like terms, okay? What is the next step according to my little setup here? Factor what? Anybody know? We're trying to get y by itself. So on this side, we can factor out a y. What will we have? Be real careful. Does everyone understand where that 1 came from? We have to be able to distribute that back and get what we had. Y minus xy, if we take out a y, would be 1 minus x. Now, can we isolate the y? What's the last step? Yep, divide both sides by 1 minus x. So we get y, or f to the negative 1 of x, equals 4x over the quantity 1 minus x. You don't have to have the parentheses when you write it algebraically, but if we're going to check it on the calculator, we do. So we had a 4x on top, divided by a 1 minus x in the denominator. Is that what we had, guys? Okay. It's pretty easy to see right here that they flipped across the blue line. It's a little bit harder, but you can tell those did as well. Okay. All right. So same process. You want to try this one on your own? Switch all the x's for y's, cross multiply, get all the y's on one side of the equal sign and everything else on the other side of the equal sign, and then factor out the y's. What'd you get when you cross multiplied? Anybody have something at that step? Good job. So y minus 1 times 1. And if you wrote them on the opposite sides of the equal sign, guys, it doesn't matter. But what do I need to do to isolate the y's now? It means I need all the y's on one side and everything that doesn't have a y on the other side. Okay, subtract the 2xy over to this side. And I need to add the 1 back over with the 5x, okay? So I end up with y minus 2xy equals over here a 5x plus 1. And then factor out the y. What's left over here? 1 minus 2x. And over here is a 5x plus 1. And then I need to divide. So I end up with the inverse function is 5x plus 1 over 1 minus 2x. Now, what have I forgotten to talk about? Anybody know? Domain restrictions, yes. Okay, what's happening on, let's go over to this one on the left here. Number 8, okay, had a domain restriction initially of x couldn't equal -4, but now the domain restriction is x cannot equal 1 because we can't divide. And over here, 1 minus 2x cannot equal 0 would be 1 cannot equal 2x. So x can't be 1/2. Does that seem right, guys? This would not have had any domain restrictions, even under a cube root, because you can cube root a negative. Here, when we ended up, we would have said x can't be 0. Good question. On the quiz, I separated that. So there's one where I ask you to find the inverse. And then there's another one where I say find the domain restriction, just because I didn't want to double whammy you on the same question. It's hard enough for these to find the inverse when they look like this, because this is what's going to be on the quiz, guys. You might want to put yourself a big check by number 9. That's the one that's going to be on the quiz, is an icky one like that. Might be an easy one too, but there's definitely going to be one like that, because that's the pre-calc part of it. All right. Inverse functions should also undo the actions of the original function. So if you put g into f like this, or f into g like this, they should undo the actions of each other and get you back to just an x. All right, we're just going to practice. Well, here's one done for you. This function is supposed to be the inverse of this. So if they put the g into the f, they had 6 over, instead of x minus 4, they put 6 over x plus 4 minus 4. Well, what would happen is the 4's would drop away, and then it says 6 is being divided by 6 over x, which means multiplied by the reciprocal, and you just get x. If you did it the other direction, and you put this one in here, you would have 6 over the quantity, 6 over x minus 4, with a plus 4 on the back. That one's a little more painful to think about, but right there it says 6 is being divided by 6 over x minus 4, then there's a plus 4 back here. Divided means you flip it over, so that would be x minus 4 over 6. This would cancel, and then x minus 4 plus 4 would be x. All right, so they undid each other. Pain in the neck to show that, but a little bit easier with this one. You have one of these to show. So let's put g into f first. So that would be this one. G is going into f. So we would write 2 times the quantity where there was an x. What are we going to put in? Anybody awake? Where there used to be an x here, we're going to put the g function, which was x minus 3 over 2. What would happen? The 2 would divide out, and then we would just have x minus 3 plus 3, which would be x. Make sure you show carefully the order that those go away in, okay? Then the other one, you're supposed to show algebraically both work. So this would be putting f into g. So putting this one in here would be, instead of an x minus 3 all divided by 2, what goes in here is a 2x plus 3. So what happens first there? 2x plus 3 minus 3 would just be 2x, right? And 2x divided by 2 would just be x. So it worked both ways, and they both had domains of all real numbers, so we're good. So you might have one of those on the homework where it asks you to show by putting one into the other that they undo each other. All right. Also on the quiz, it will ask you to graph the inverse by switching the XY ordered pairs. So do you have these two or not? You don't have these two? Okay. So just help me real quick. Where is this ordered pair up here going to go? It was 0, 3, so it's going to go to 3, 0. And like this one was -2, -1, so it's going to go to -1, -2. You don't change signs, you just reverse the ordered pairs. So the inverse would look like that. Okay? On this one, 0, 0 would still be 0, 0. Like it looks like it's going through 30, let's see, 10, 5 maybe. So that would be 5, 30, somewhere up here. It almost looks like it's going through 70, 10. So if we went to 10, it would be almost up here to 70. It would just be doing a really little, does that look like it reflected, guys? Okay. So our job is to graph the inverse of this. Ugh. This is kind of painful because it goes through 1, 1 and 0, 0. What are the inverses of those 2 points? Yes, 1, 1 and 0, 0. That's not a really big help. But if you picked something in here, like 1/2, it's almost up to 1. It's like 0.9. So at 0.9, it's only at like 1/2. It's actually doing this, guys. Yes. And then out here, it goes through 2, 2, it looks like, so that's still going that way. And then way out here, it's like at 3, 8, so that's the 1, 2, 3, 4, 5, 6, 7, 8, 3 would be here. But it should be doing this little flip-flop thing here where the, yes. Okay. Because again, it should look like it was reflected across this line. Whoa, that's not going to work well. Let's try this line. The line y equals x. There we go, and I can make it dotted. Okay, should look like it flipped across that line. Mine is not great. All right, there is one of those you have to do on the quiz, so you're going to want to find a few ordered pairs and try to flip them. All right, we got 3 more minutes, so I'm going to talk real quick about this idea of restricting a domain. The normal parabola y equals x squared, f of x equals x squared. Is this going to have an inverse function? But how could I restrict it so that it did? Yes, I could say the domain I want is only like 0 to infinity, right? So I cut off this half. We could also cut off the other half if we wanted. Okay. So then when you reflect it, it's going to look like this, and it'll be a square root graph. Okay. The inverse function would be the square root of x, okay? Where the range now will be 0 to infinity. The domain is also 0 to infinity. All right, we don't have a lot of time, but I want to talk a little bit about this. This formula is converts Celsius to Fahrenheit, guys. Celsius into Fahrenheit. So what would the inverse function do? It would convert Fahrenheit into Celsius, okay? They want you to find that equation and then put one inside the other or graph them and show that they're inverses, okay? Now, here's the function for Kelvin. This is Fahrenheit to Kelvin. If we put F in here, it would convert Celsius directly into Kelvin, because we said we're going to put the function f of x, what's converting Celsius to Fahrenheit, and then we're going to put it into the function that converts Fahrenheit to Celsius to kelvins. So we'd have a formula that converted Celsius directly into kelvins. All right. This is the assignment tonight. A couple of them towards the end are word problems you may have to ask about later. But it is on page 70 in your book, and I will attach the PDF of the bookwork in the Google Classroom, so you can just pull it open on there if you want. Did everybody pick up the homework checklist in the back? Okay, this is number 2 already, right? You had 1.6 before you had your long weekend, and this is 1.7. We are quizzing on Friday this week, so don't fall behind or you're going to have too much.